Welcome to ETE MCQs. Now let us solve a problem in digital circuits. So we are given the block diagram of a 4 to 1 multiplexer. The question is, identify the output Y of the following circuit. So we have got a 4 to 1 multiplexer. The selection lines are taken for towards A and B, A for S1 and B for S0, and C is the third input that is taken along the third variable that is taken along the inputs. So it is a three variable function. The output function Y is going to be a three variable function, and we are supposed to identify which among the four functions is implemented in the given multiplexer or using the given multiplexer, 2 to 1 multiplexer. So before we proceed further, let us just see the basic truth table and the respective Boolean function, output function of a multiplexer. The truth table can be of this form. The selection lines are S1, S0. The output is Y. So the four possible cases you can have for S1 and S0 are 0, 0, 0, 1, 1, 0 and 1, 1. Now what is basically a multiplexer? Multiplexer is basically a many to one. In general, it is considered to be a many to one circuit, which means that you will have, in this case, you will have 2 power n possible combinations of input. One among the 2 power n possible combinations will be taken to the output. In this case, then n refers to number of selection lines. Number of selection lines. Okay, and the number of inputs is 2 power n. 2 power n refers to number of inputs you have. So number of inputs is represented by 2 power n, and the number of selection lines is given by n. Now, since one among the 2 power n possible combinations has to be taken to the output, for 0 and 0 combination, the output in general, you can have 4 inputs to a multiplexer, which can be roughly modeled as a basic 4 cross 1 mux will be of this form. 4 inputs, 1, 2, 3 and 4, that is 2 power n is 4. You have 2 selection lines. These two are selection lines, which is given by S1, S0, and let the inputs be taken as I0, I1, I2 and I3. 4 to 1 mux multiplexer. So this is all we have. Now the outputs has to be for 0 and 0 combination. I0 should appear at the output, only then the functionality of multiplexer is justified. For 0, 1, I1 should be available at the output, is produced at the output. For 1, 0, the input I2 is passed on to the output, and for 1, 1, the input I3 is passed on to the output. Now let us just write the respective Boolean expression based on inspection. For the output, the Boolean expression has to be Y is nothing but, since S1 is 0 and S0 is 0 for the first case, and the respective output is I0, you can say that the term can be modeled as a product term as S1 bar, S0 bar, because S1 and S0 both are 0, and I0 is the input that is passed on to the output, so you take it as such. S1 bar, S0 bar, I0, plus for the second term it is S1 bar, S0, I1, S1 bar, S0, I1, plus here it is S1, S0 bar, S1, S0 bar, I2, plus the last term is S1, S0, I3. So this will be the Boolean expression we get. Okay, so this is just a glimpse on the basic truth table and the respective Boolean expression for the output function of a 4x1 multiplexer. Now let us just try to make use of the points that are understood, the concept that is understood over here. Let us try to apply it over to the given problem, and let us try to find the function which corresponds to the output y. So to solve the problem, let us start with the function table of the given combinational circuit implemented using 4 to 1 multiplexer. We will have the selection lines are represented by A, B. The output is represented by Y. And the 4 possible combinations for selection lines we will have is 0, 0, 0, 1, 1, 0 and 1, 1. For 0 and 0, C is available or produced at the output. For 0, 1, C bar is produced at the output. For 1, 0, 1 is passed on to the output. And for 1, 1, 0 is passed on to the output. Now let us just try to construct the Boolean function, okay, similar to what we have done here. The respective Boolean expression for the given combinational circuit is A bar for the first row in the table, combination of selection lines, A bar, B bar, C, A bar, B bar, C plus A bar, B, C bar plus A, B bar, dot 1. It is actually dot 1. And then plus A, B taken Boolean ANDed with 0. So this becomes 0. We will finally have Y is equal to A bar, B bar, C plus A bar, B, C bar plus A, B bar. This is all we have. Now, in order to get the equivalent, the function output should be completely expressed in terms of min terms. I can notice that this one is a min term, this is a min term, this is also a min term. A min term is nothing but all the variables should be available in the product term, either in its actual or complemented form. That is the min term. In its actual or complemented form. That is your min term. You can notice this is a min term where A is 0, B is 0 and C is 1. This is a min term with A is equal to 0, B is equal to 0 and C is equal to 1. And here A is 0, B is 1 and C is 0. Whereas here C is not available. Okay, the variable C is missing. So we are supposed to make this product term a min term. So in other words, this 1 can be rewritten as, based on the Boolean laws, I can rewrite this 1 as C plus C bar. This is valid. C plus C bar is equally valid because if C is 0, C bar is 1 and C is 1, C bar is 0. So the Boolean OR operation of these two is going to be 1. So 1 is equivalent to C plus C bar. Now you perform the Boolean AND operation, you will get 4 min terms. Boolean expression can be rewritten as A bar, B bar, C plus A bar, B, C bar plus A, B bar, C plus A, B bar, C bar. Okay. Now that the output function is completely expressed as the Boolean OR operation of min terms. Okay, each and everything is a min term. Each and every product term you have in this Boolean expression is a min term because it has got all the variables A, B or C is there in all the product terms, either in its actual or complemented form. So the respective binary representation for this product term is, min term is 0, 0, 1. Here it is 0, 1, 0. A is 1, B is 0, C is 1. A is 1, B is 0, C is 0. Now that we have expressed the output function y completely in terms of min terms, we can also obtain the output function, represent the output function, okay, in SOP form, in sum of products form, and the integer values of this binary representation will help you to complete the function. Okay, so the output y is equal to f of a comma b comma c is equal to summation m. You have 001 is 1 in decimal, 010 is 2, and 100 is 4, and 101 is 5. So this will be the resulting output function in SOP form. So this 4x1 multiplexer implements a 3 variable function whose Boolean expression is given here, and its SOP form is given as summation m 1, 2, 4 and 5. So option B is the correct answer. Thank you.